Hello, everybody. My name is Asante, and in today's lab, we'll be investigating motion of a falling object. So to start off, I made two computational models, one for motion with auto drag force. As you can see here, the green arrow represents the gravitational force acting on the object. The second one is a model of motion with a drag force. The drag force is represented here by this light blue arrow at the top, and here represented by the orange arrow again, is the gravitational force. Here's the real life model I made of a ball falling. And then here is the code I made to produce the computational models. This one is for motion without a drag force. And then this is the code I used to make the model for motion with a drag force. Okay, so after that, I collected data from the models and from the graph and from the real life model to make a graph. The blue line represents the real model. The gray line represents the model without drag, and the orange represents the model without drag. So as you can see here, this is a graph of vertical position of the object against time. Obviously, the discrepancy between the real life and the models is maybe due to air resistance or error that may have occurred or other human factors. As you can see here, the motion without drag is lower, has a higher magnitude than the motion with drag, and also higher than both models have a higher magnitude than the real life model. So conclusion, when a net force is applied, the ball moves at an inconsistent speed in one direction, i.e. inconsistent velocity. This proves Newton's second law, which states that Vf equals Vi plus F net over m over t. Since the magnitude of Vf isn't equal to Vi, this proves that there is a net force acting on the ball. Along the horizontal, motion doesn't change in the x-axis, so it travels along one axis because the net force in the x direction is zero. Because in this experiment, the only forces acting on the ball are gravity and drag. Hypothetical, later on, if we had carried on the experiment for a longer time, we would have seen the ball reach a point where it moves at a constant velocity, and then there's no acceleration due to the drag being equal to the gravitational force and therefore net force being zero. If more drag was added, for example, air was blown from under the ball wouldn't travel as quickly and would have reached its maximum velocity sooner. Hypotheticals made, there weren't many hypotheticals made. The only assumptions made, the only one was the ball only travels along the y-axis. It doesn't deviate doesn't travel along the x-axis or the z-axis, only travels vertically. That's it for today. Thank you for your time, and I hope you enjoyed this.